Hello students, welcome to Kinetics, Kinetic to Apex. Let us discuss the first chapter of your class 10th mathematics, real numbers. So before going to real numbers, let us understand the number system. What is number system? Number system is basically a way of classifying the numbers based on their properties. That means number system is a big family of numbers. What it contains? It contains the real numbers. So real numbers can be classified to two main types. One is a rational number, another one is irrational number. Under rational number comes the first type, that is natural numbers. So natural numbers means when we will say the counting numbers 1, 2, 3, these are the natural numbers. Then comes 0. When 0 is added to these natural numbers, it becomes whole numbers. Therefore, natural numbers and 0, it becomes whole numbers. Then comes the requirement of the negative numbers. So let us say there is some depth. The temperature is very low. We will say the temperature is minus 18 degrees centigrade. So that's why comes the requirement of the negative numbers. So negative numbers, 0 and the natural numbers are as a whole called as integers. Then comes the real numbers. So basically what is real number? Real number are the numbers on the number line, and any number that you can present on a number line, that is a real number. As we discussed, real number is of two types. One is your rational number, another one is irrational number. Another type of number comes that is little bit different, that is known as the complex numbers. Complex numbers means there is a term, that is an imaginary term, that is I comes into play. So a plus ib. So whenever I will be there, that will be a complex number. What is I? Root over of minus 1 is I. So this is all about the number system. So we have here represented all the number systems in the form of a number line. Let us say this is 0. So from 0, 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, these are the natural numbers. Natural numbers with 0 becomes the whole number. Then this whole number with negative numbers becomes the integers. Then any number in the form of p by q may be positive, may be negative. That is a rational number. Numbers such as pi, e, which is not terminating and not repeating, is known as the irrational numbers. We'll discuss in details in the next slide. So here we have represented the entire number system. So as a whole, we are calling as real numbers. Real number categorized into two types: rational numbers, irrational numbers. Under rational numbers, first comes the natural numbers, that is the counting numbers 1, 2, 3, 4, 5. These are the natural numbers. Then natural numbers added with 0, it becomes whole number. Whole number added with negative numbers minus 1, minus 2, minus 3, it becomes integers. Then on the number line, anything in the form of fraction, may be positive fraction, may be negative fraction, it becomes the rational numbers. Then comes irrational numbers. The root 2, root 3, root 5. These are, you see, the value of root 2. 1.41421356. Likewise, it continues. So, it is not terminating and the numbers are not repeating. That's why this is known as irrational numbers. I'll explain in details about these rational numbers and irrational number in the next slides. So basically what we have understood is anything that can be represented in the form of P by Q is known as rational number, where Q is not equal to 0. If Q equal to 0, the value will be infinite, hence it will not be a rational number. Important concept, Q should not be equal to 0, then only it will be a rational number. So, rational numbers can be represented in the form of positive fractions like 1 by 2. 1 by 2 means 0.5. 3 by 4, that is 0.75. 7 by 10, that is 0.7. So, these are the positive fractions. It can also be represented in the form of negative fractions, that is minus 2 by 5, minus 7 by 3. These are the negative P by Q format. All the whole numbers can be called as rational numbers, because let us say whole number, that is 5. 5 can be presented as 5 divided by 1. 7 equal to 7 divided by 1. So any whole number is with a denominator of 1, hence we can say all the whole numbers are rational numbers. Let us say 0. 0 can be presented as 0 by 1. So this is a rational number. Next, the finite decimals. Let us say 0.25. 0.25 means we know 25 divided by 100. That means the value is 1 by 4. So this is a finite decimal. 0.75. That means this is 3 by 4. So this is also finite decimal. This is rational number. Last one is interesting, repeating decimals. Let us say 1 by 3. That means the value is 0.333 dot dot dot. So that means the number 3 is repeating after the decimal. That's why we can say this is a repeating decimal, but this is a rational number. Similarly, 2 by 3, that means 0.6666. Then likewise, it continues like that. That is a repeating decimal. So 2 by 6 is also a rational number. So this is all about the rational numbers. Now let us move to the irrational number. So here there are two important things in case of irrational number, that is non-terminating. Non-terminating decimal, and the decimal is not repeating. So non-terminating and not repeating. That is, these are the two properties of the irrational number. Here you see in root 2, root over of 2, this is 1.4142136. This is not terminating. It continues like that. Okay, and the numbers are not repeating. Not repeating means it is not following a particular specific format, like 0.333, that is number 3 is repeating. Here likewise there is no specific number that is repeating. Then the square root of numbers that are not perfect squares are irrational. So what is perfect square? Let us say 4. 4 is a perfect square. Square root of 4 is 2. So 2 is a rational number. 9. 9 is a perfect square. Square root of 9 is 3. 3 is a rational number. Whereas square root of 2, square root of 3, square root of 5, 2, 3, 5, 7, these are not perfect squares. So the square root of numbers that are not perfect squares are irrational. So here we have written that one, that is root 2, root 3, root 5, root 7. These are the irrational numbers. Excluding these, the mathematical constants like pi that we use for getting the area of the circle or the perimeter of the circle, the value of the pi is 3.14159265. Likewise, it continues. So that is an irrational number. Similarly, E that is the base of natural logarithm, the value is 2.71828. Likewise, it continues. This is an irrational number. So these are the irrational numbers. Like we have discussed, root 2, root 3, root 5, root 7. These are the non-perfect squares, the mathematical constants. These values are irrational numbers. Hence, we can say the number that cannot be expressed as the ratio of two integers, that is, that cannot be presented in the form of P by Q, we'll call it as irrational number. Based on what we have discussed, let us solve some MCQs. Which of the following is an irrational number? You see 7 by 3. 7 by 3, it is in the form of P by Q, hence it is a rational number. 0.75, that means 3 by 4. This is also rational number. Root 2. Root 2 is an irrational number. 5 is also a whole number, so that is also a rational number. 5 means it can be represented as 5 divided by 1. So again, it is in the form of P by Q. So it is also a rational number. Here answer will be C. Root 2 is an irrational number. Next, which of the following numbers is rational? Pi. Pi is an irrational number. Mathematical constant that we have discussed. Root over of 5 is an irrational number. Then minus 9 by 4. Yes, minus 9 by 4 is in the form of minus P by Q form. So this is a rational number. Hence here answer will be C. Minus 9 by 4 is a rational number. Again, E is the base of natural logarithm. This is an irrational number. Coming to the next question. The decimal expansion of which number terminates? Here in option A, the value is 3 by 8. 3 by 8 means 0.375. Here it terminates there. So hence the answer will be A, that is 3 by 8. In case of B, this is 2 by 3. 2 by 3 means 0.666, like it continues. Okay, so 2 by 3 is a rational number, but the decimal expansion of this number is not terminating, but it is a rational number. Root 3 is an irrational number. Pi is an irrational number. So here answer will be A, that is 3 by 8. The decimal expansion of 3 by 8 terminates. Next question. Which of the following is a real number but not rational? A real number but not rational, that means it is an irrational number. So it is obvious root 7 is an irrational number. 2 is a rational number, that is represented as 2 by 1. 5 by 2, it is in the form of P by Q, so it is also a rational number. 0 can be presented as 0 by 1 or 0 by 2 or 0 by 5. So 0 can be presented in the form of P by Q. Hence 0 is a rational number. All whole numbers are rational numbers. Next question. If x equal to root 2 and y equal to 7 by 3, then which is true? Here x equal to root 2, that means x is irrational. Y equal to 7 by 3, that means y is in the form of p by q. Hence y is rational. That's why the answer will be option B. X is irrational, y is rational. So, thank you. Overall, we have discussed about the real numbers. To summarize, real number contains rational numbers and irrational numbers. A rational number, the number that can be presented in the form of P by Q is a rational number. That cannot be presented in the form of P by Q is an irrational number. Irrational number means after decimal it is not terminating, it is not repeating. That is unsatisfied, it goes on, continues. So non-terminating, not repeating, that is irrational number. Under rational number, you have natural numbers. Natural number, that is 1, 2, 3, 4, 5, the counting numbers. That natural number plus 0 gives the whole number. The negative numbers plus whole numbers, you are getting the integers. Then the number in the form of fraction or in the form of p by q are the rational numbers. This covers the entire whole real number. So I hope you have enjoyed the video. Your support matters a lot. Like, comment, share and subscribe for more similar content. In the next video, we have the more content about the real numbers. Thank you. Thank you for watching.